Now we have to find out the current in this circuit. Problem is find the current in the circuit. Now by seeing the circuit diagram itself, we have to analyze which are the resistors in parallel, which are the resistors in series, and ultimately draw one or two equivalent circuits so that you can solve the problem easily. By seeing this, we can conclude that these four ohms, these two 4 ohms are in parallel combination. Similarly, these two 4 ohms are also in parallel combination. This combination and this combination is in series combination. So first I resolved these two. Again, after drawing this equivalent circuit, you can know that these three are in again parallel. First I will draw for this. This 4 and this 4 is in parallel combination. That means what happens? Parallel means 1 by R is equal to 1 by R1 plus 1 by R2. 4 LCM 1 plus 1, that is 2 by R. This is 1 by R value. But R value is equal to 4 by 2, that is equal to 2 ohms. So for this 4 ohms and 4 ohms, equivalent value is 2 ohms. Similarly, this is also 4 ohms and 4 ohms. So no need to calculate again. This is 2 ohms only. That means this 2 ohms are in series with 2 ohms. So what happens? In series combination, resistance will add up. That means 4 ohms. So this 4 ohms, here we find out that this is also 4 ohms. 4 ohms and 4 ohms are is in parallel. That means now the equivalent circuit will come like this. 4, 4, 4. This is 4, this top one. This we find out that this is 4. And bottom one is also 4. Other than this, what we have? 2 by 3 ohms here. Now for this 4, 4, 4, we have to find out again equivalent resistance. So 1 by R is equal to 1 by 4 plus 1 by 4 plus 1 by 4. Again 4 LCM, 1 plus 1 plus 1, 3 by 4. This is 1 by R value. Now R is equal to 4 by 3 ohms. Now for this, all the three resistors, the equivalent value is 4 by 3 ohms. Now again one more equivalent circuit I will draw. If you are able to do without drawing equivalent circuit also, you can do it roughly, no problem. But this is 4 by 3 ohms. This is 4 by 3 ohms. Now one more 2 by 3 ohms is left here. And the battery is 1.8 volts. Now this 4 by 3 ohms is in series with 2 by 3 ohms. Instead of drawing here, I drawn here 2 by 3 ohms. So series combination resistance will add up. That means 4 by 3 plus 2 by 3. 3 LCM 6 by 3. That means 6 by 3 means 2 ohms. So R is equal to 2 ohms. So the final equivalent circuit is total resistance, equivalent resistance in this entire circuit is 2 ohms only. So by seeing this diagram, it is very complicated like that. So what is the final value of the resistance? All these resistors, only 2 ohms. So if you want, you can draw one more diagram. Otherwise, you can straight away do Ohm's law. So 2 ohms is only the equivalent resistance. So if you want, we can draw one more diagram. This is battery and 2 ohms is the equivalent resistance only. So for this entire circuit, what is the resistance? We find out 2 ohms only. So 2 ohms only there, and the battery is 1.8 volts. Now V is equal to IR. Therefore 1.8 volts is equal to I into R is equal to 2. Therefore I is equal to 1.8 by 2. This is 0.9 amperes. See how easy it is. By seeing this circuit diagram, no need to worry. We have to solve one by one step. We have taken these two parallel, again these two series, again all the three parallel, again this parallel is in series. So ultimately we got 2 ohms is the equivalent resistance. So with that we applied V equal IR. If you don't want to draw equivalent circuits every time, no need to draw. You can straight away solve the problem. No need to draw every time equivalent circuit. But equivalent resistance, either we have to apply either parallel combination or series combination, find out the equivalent resistance, then find out the current. This is the way we have to do. Similarly, we can solve one or two problems, then we will discuss about Wheatstone bridge and all. If you like this, you please subscribe the channel, and if you have any other doubts other than these what I am discussing in CBSE book or any state board books, you please ask me. I can upload the videos.